50 of those degrees are taken up, that leaves me with 130 left. And then these two angles are both going to be congruent. So if I have 130 degrees remaining for those two equivalent angles, I could just divide by 2, and I'm going to get 65. So my y then is going to be 65 degrees. We can head over to number 9 to check out those angles as well. So same idea, we got isosceles triangles, so those two angles are going to be congruent, and then those two angles are going to be congruent as well. So first, I've got 125 degrees that I'm looking at. That 125 degrees with angle x are going to make a straight line. So that means that angle x is going to be 180 minus 125, which is going to equal 55 degrees. So angle x would be 55. And there we could write that in. So it makes a linear pair with the 125. That'll be then 55 degrees. And that also means since x and the other triangle, we have a vertical angle, this angle in here, that's also going to be 55 degrees in there. And the same idea as before, I've got the remaining degrees left for angle y and its congruent angle. So if I have angle y and its congruent angle, the remaining degrees left in that triangle is 125. I would divide that by 2. That's going to give me 62.5. So I know that the triangle is an isosceles triangle. 55 of the degrees are taken up. That's going to leave me then with 125 degrees to split between those two congruent angles. Heading down to example 10. So we've got a 25 and 25. So I could look at this then. This whole thing is going to be 50 degrees. And we've got an isosceles triangle. So this angle here and that angle there are both going to be congruent. So I'm going to take 180 minus 50. That leaves me with 130. Divide that 130 by 2. That would leave me with 65. So x would equal 65 degrees. Now looking at what's remaining, I've got a triangle here. I'm going to try to highlight it. I know things are getting a little sloppy here, but I've got a triangle here with this y. I've got a 25-degree angle. I've also got a 65-degree angle. That adds up to 90 degrees. So what's remaining then is another 90 degrees. So y is also going to be 90 degrees. So if I know that the two angles are 25 and 65, that's taking up 90 of the total 180 in that triangle, and that's how many degrees then I would have left. Lastly, if I have a equilateral triangle, all the sides are going to be equivalent, so 7 would be my x, and then all the angles are always going to be 60 degrees. So in 11, I'd have a 7 and then a 60. So there would be our answer for number 11. So using some hints about the isosceles triangles, if I have one angle in isosceles triangle, really I do know all three angles because I can subtract off the angle I know, and then the other two I can just split evenly by dividing by 2, and then I can find those two remaining angles. So I am going to delete this screen, and we're going to just take a look at one additional proof. So if you want to get back to this, I'll post this video. You'll be able to see the video on our schedule here right after we're done with class here. So I'll delete that. Let's head down, look at number 14 next. So we get one proof practice. So looking at our proofs, we're always going to start out with the given. So we're going to have angle D is congruent to angle C, and then B is the midpoint of AE. And that's just going to be my given. So when we have our test, we'll also have those fill in the blank proofs. So it'll be very similar to our quiz. So remember that given is always going to be your very first step. Next, I would look at my diagram. First, the given, I probably should have mentioned this. I'll mark C and D. So there's one angle I can prove that they are congruent. And then I'm eventually trying to prove that DB is congruent to CB. So since I'm not proving triangles congruent, that means my last step is going to be CP-CTC. So I'm just going to make a little note there. To get the parts congruent, I'm going to use that CP-CTC once I get the triangles congruent. And at any time, you guys can buzz in or interrupt me if something doesn't make sense, or even if I make a mistake, because that's been known to happen as well. So I start now at number 2. I'm going to look for something I can tell without having any markings, and that's going to be right here. So I've got vertical angles, so we'll get another angle congruent between the two triangles. I'll say angle ABC is congruent to, since I started with A, I'm going to have to go EBC on the other side. There's going to be my two congruent angles, and my reasoning is going to be vertical. So since those are vertical, then those are going to be congruent. So far, if you're kind of keeping track, we've got an angle, and we've got another angle between the two, but we still need one more piece. And looking back at my given, there's another thing I can use for my given. B is the midpoint of AE. So AE is this segment, so I can mark number 3 is AB is congruent to EB, and that's because of definition of midpoint. So there would be my reasoning. Now if I look, I've got an angle and an angle, and now a side between the two. So I can now prove the triangle is congruent, which is what I'll do before I get to CP-CTC. So number 4, we'll say that triangle ABC is congruent to triangle EBC, and that's because of angle, angle, side. And lastly, we're not proving the triangle is congruent, we're proving those two parts congruent. DB would be congruent to CB, and that's because of CP-CTC. Not CPP, CP-CTC. So there would be my full proof. Once the triangles are congruent, I can now prove any parts are congruent with that CP-CTC. So I will post that